Have you ever wondered how Java handles errors and executes multiple tasks at the same time? Let's delve into the fascinating world of Java exception handling to answer this question. Exception handling in Java is a powerful tool that allows developers to manage and respond to errors and unexpected conditions during program execution. It's like a safety net, preventing your program from crashing and enabling it to handle errors gracefully. So, what exactly are exceptions? An exception is an event that disrupts the normal flow of your program. Picture it like a rock on a highway, causing your car to swerve off its path. It could be triggered by various issues such as invalid user input, a resource being unavailable, or even a programming error. But don't worry, Java's got your back. It uses a structured approach to handle these exceptions, allowing you to catch and address them without abruptly terminating your program. It's like having a spare tire in your trunk, ready to replace the flat one. This is where try-catch blocks come into play. They are like your program's emergency response team. The try block contains the code that might throw an exception, and the catch block is there to handle the exception if it arises. Now, what about the finally block? It's like the cleanup crew that comes in after the emergency. The finally block is executed whether or not an exception is thrown, allowing you to tidy up resources or perform any other final actions. Java also gives you the power to throw exceptions explicitly using the throw keyword. This can be super useful for custom error handling and validation. It's like being able to trigger your own emergency to test how well your program can handle it. And what's more, developers can create custom exceptions to represent specific error conditions in their applications. It's like designing your own unique emergency drill. Java also has several built-in exception types, grouped into checked and unchecked exceptions. But we'll dive deeper into those in the next scene. So, you see, exceptions in Java are not just errors, but opportunities for enhancing the robustness of our programs. Now, how exactly does Java handle an exception when it occurs? Well, Java uses a tool called the try-catch block. This is a mechanism that allows us to define a block of code that might throw an exception, and another block of code that will handle this exception if it occurs. Imagine the try block as a testing ground. This is where we put the code that might cause an exception. The catch block, on the other hand, acts like a safety net, ready to catch any exceptions that might be thrown by the try block. If an exception does occur, the catch block springs into action, handling the exception and preventing the program from crashing. Now let's dive a little deeper. In the try block, we place the code that we suspect might cause an exception. It's like saying, let's try this and see if it works. If an exception does occur, the flow of control immediately switches to the catch block, bypassing any remaining code in the try block. The catch block, on the other hand, is there to, well, catch the exception. It contains the code that will be executed if an exception is thrown. It's our safety mechanism, making sure any exceptions are handled gracefully and our program can continue to run. But what if we want to throw an exception ourselves? In Java, we can do this using the throw keyword. This allows us to manually throw an exception when we detect a condition that we cannot or do not want to handle. For example, if our program encounters an invalid user input, instead of trying to process it, we can throw an exception to indicate that something went wrong. With try-catch blocks and the ability to throw exceptions, we can manage unexpected situations effectively in our Java programs. These tools give us the power to dictate how our program reacts to errors and exceptions, making our code more robust, reliable, and user-friendly. So remember, when it comes to handling exceptions in Java, the try-catch block is your best friend, and the throw keyword is your secret weapon. And with that, we've explored the basics of try-catch blocks and throwing exceptions. But stick around, there's plenty more to learn about Java exception handling and multi-threading. But not all exceptions are created equal, are they? In the world of Java, exceptions come in a variety of shapes and sizes, each with its unique characteristics and ways of handling them. First off, we have checked exceptions. These are the pesky ones. They are exceptions that must be either caught or declared in the method signature. You can think of them as the strict teachers in school who insist that you must handle your responsibilities. If you've worked with file operations or databases, you've likely encountered these in the form of IO exception or skill exception. Then we have unchecked exceptions, the rebels. Also known as runtime exceptions, these do not need to be explicitly caught or declared. They usually occur due to programming errors and can be avoided with a bit of precaution. Common examples include arithmetic exception, which is thrown when you attempt to divide by 0, null pointer exception, which pops up when you try to access an object reference that's null, and array index out of bounds exception, which occurs when you try to access an array element beyond its size. Now, wouldn't it be great if we could have exceptions that are specific to our application's needs? Well, Java's got you covered. You can create custom exceptions to represent specific error conditions in your code. These give you the power to define your own rules and can make debugging and error handling a lot more meaningful and efficient. So how do we distinguish between these types of exceptions? It's all in the handling. Checked exceptions demand your attention. They need to be caught or declared, otherwise your program won't compile. Unchecked exceptions, on the other hand, don't stop the compilation. They're like hidden pitfalls, revealing themselves only at runtime. And custom exceptions? They're your playground. You decide their behavior, their messages, and when they should be thrown. Understanding the types of exceptions helps us to handle them appropriately, making our code more reliable and robust. So next time you encounter an exception, remember, it's not just an error. It's an opportunity to improve your code and learn something new. Now, let's shift gears and dive into the world of multitasking with Java's multithreading. Multithreading in Java is a powerful feature that allows us to execute multiple tasks concurrently. This capability significantly enhances the performance and responsiveness of our applications, making them more efficient and scalable. It's especially useful in developing server-side and real-time systems, where the ability to handle multiple tasks simultaneously is crucial. Now you might be wondering, what exactly is multithreading? Well, multithreading involves running multiple threads or lightweight processes within a single program. Each thread operates independently, performing its own task while coexisting with other threads in the system. Imagine a busy kitchen in a restaurant. Each chef is a thread working independently but in harmony with others to prepare multiple dishes at once. This is the essence of multithreading. It's all about maximizing efficiency and productivity. The beauty of multithreading lies in its ability to perform multiple tasks simultaneously. This can markedly improve the efficiency and responsiveness of our applications. For instance, while one thread is waiting for a resource to become available, another thread can continue executing. This ability to switch between tasks ensures that our program is always making progress, even in the face of delays or bottlenecks. Creating threads in Java is a straightforward process. Java provides two primary ways to create threads. First, we can extend the thread class and override its run method. Alternatively, we can implement the runnable interface and define the task in the run method. Both approaches are effective and can be used based on our specific needs and preferences. However, multithreading isn't without its challenges. When multiple threads access shared resources, there's a risk of data corruption if they interfere with each other. This is where synchronization comes in. By using synchronized blocks, we can ensure that only one thread can access a particular resource at a time, guaranteeing thread safety. Multithreading in Java opens up a new dimension of efficiency and responsiveness in our applications. So, how do we introduce multithreading into our Java programs? Well, let's dive right in. There are two main ways to create threads in Java. The first is by extending the thread class. In this approach, we create a new class that extends the thread class and overrides the run method. The run method is where we put the code that we want our new thread to execute. The second way is by implementing the runnable interface. This approach involves creating a class that implements the runnable interface and overrides its run method. The runnable interface is particularly useful when multiple threads need to share a common resource. Once we've created our threads, we can start them with the start method, which invokes the run method in a new thread of execution. From there, our program can carry out multiple tasks concurrently, making it more efficient and responsive. Now let's talk about synchronization. Imagine two threads trying to access the same resource at the same time. Without proper management, this could result in data corruption, as one thread might modify the resource while the other is still using it. That's where synchronization comes in. Synchronization in Java is all about controlling the access of multiple threads to shared resources. By using the synchronized keyword, we can create synchronized blocks of code. Only one thread can access a synchronized block at a time, thus preventing data corruption and ensuring thread safety. It's important to note that while synchronization helps maintain thread safety, it can also lead to thread contention, where multiple threads try to access the synchronized block and are put on hold, waiting their turn. So it's a powerful tool, but one that should be used judiciously. In conclusion, creating threads and managing their access to shared resources through synchronization are key aspects of multithreading in Java. These techniques allow us to build programs that can do more and do it faster by performing multiple tasks simultaneously. With the power of multithreading and synchronization, we can create high-performing thread-safe applications in Java.